A set is nothing but well-defined collection of objects, empty set. So empty set is also called as null set or void set. Finite is nothing but countable. You can count a number of elements inside the set. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So I'm welcoming you to the second session of the chapter Sets. Let us see what are the concepts we have learnt in the session 1. So definition of a set. So what do you mean by set? A set is nothing but well-defined collection of objects. A collection cannot become a set. It must be well-defined. The elements in the set should have some unique or single property to form a set. For example, when I say good cricket players in the world, you cannot write or you cannot consider them as a set. Number of boys in your class is a collection of set. Similarly, good books in a library is not a set, whereas number of questions in the chapter set is a set. So set is nothing but a collection or a well-defined collection of objects. Also, we have learned representation of sets in two types. What are those? One is roster method and the other one is set builder method. So roster method is nothing but listing the elements. So listing the elements, whereas set builder method is nothing but describing its property. Describing the property of the elements inside the set. For example, so if I take set A as ovals in English alphabets, ovals in English alphabets. So here is what I am doing. I am describing the set. So this is one type, that is set builder form. If I write the same set as A, E, I, O, U. So here listing the ovals of English alphabets, that is roster method. Both are same, but writing is different. So here we are describing its property, whereas here we are listing all the elements which are the ovals in English alphabet. This is how we have learnt representation of sets in two forms. One is set builder method, another one is roster method. Also we have learned how we can write or how we can convert the elements from roster form to set builder and how we can write the elements when we have given a question in set builder form to roster form. Also remember, always you should denote the set with capital letters and elements inside the set must be written in the small letters separated by comma. Do not repeat any letters inside the set. Also, order of the set doesn't matter. For example, if you have an elements like 1, 2, 3 and you can write this is in another form 3, 2, 1. So the order is not important here. The thing is you should write all the elements inside the set. Don't worry about the order. So in today's session, we are going to study the types of sets. So we have many types of sets. Along with that, we are learning what do you mean by equal sets. In types of sets, you have mainly null set, singleton set, finite and infinite. Along with that, we are going to study what do you mean by equal sets. So let us start with empty set. So empty set is also called as null set or void set. So what do you mean by empty set then? Empty set, as the name itself says, U does not contain any element inside the set. That is a set which does not contain any element. So it does not contain any element, that is called as empty set or null set or void set. So, and it is always denoted by the symbol, a Greek letter called phi, or you should use the symbol with empty braces. Do not write like this. This is not how we denote empty set. Either you should write the symbol phi or you should write empty braces to denote a null set. Now we have taken an example. A contains all those elements x such that x lies between 5 and 6 and x is a natural number. We know that natural number starts from 1, 2, 3, 4, 5, 6, 7, etc. But we does not find any natural numbers between 5 and 6. After 5, you have 6. But in between, you can't see any natural numbers between 5 and 6. So therefore, I can write this set A as empty. So this is a set builder form. So they have described how this empty set is. We can describe empty set also. So here they are describing the empty set. So this is an example for empty set. Well, set B, set of odd natural number divisible by 2. What are odd natural numbers? 1, 3, 5, 7, etc. So what is the condition given here? Divisible by 2. Any odd natural number is not divisible by 2. So therefore, set B is also empty. So I said you can write either this symbol or using empty braces. So this is how we denote set, and these are the examples for null set. Next, singleton set. As the name says, singleton set contains only one element inside it. That is a set which contains only one element. So it should contain only one element. Examples are given here. The set of even prime numbers. We have only even prime numbers. What are the prime numbers we have? 2, 3, 5, 7, 11, 13, etc. So this is a set of prime numbers. But the only even prime number is 2. So therefore, this is an example for singleton set. Next, they have given a condition. B contains all those elements of x such that, what is the condition of x? X must be natural number and x square is equal to 25. So I have given here B is equal to 5. Why x square is equal to 25 means x can get the values of plus or minus 5. But what is the condition given here? X must be natural number. According to this, here x can be minus 5 or plus 5. Since minus 5 is not a natural number, the only natural number for this equation is 5. So therefore, B contains only the element 5. That is, it contains only single element. Therefore, it is called as singleton set. So now we'll take few questions. So, which of the following are examples for null set? Set of odd natural number divisible by 2. I said earlier, any odd natural or any odd numbers cannot be easily divisible by 2. So therefore, this is an example for null set. Okay. Set of even prime numbers. So even prime numbers is only 2. You have one element in it. So this is not null set. Null set means it should not contain any element. But here you are having the element 2. So therefore, this is not an example for a null set. And here we have x such that x is a natural number, x less than 5 and x greater than 7. You cannot find any natural number which is less than 5 and greater than 7. So this set is empty. So this is an example for null set. So whenever the set is empty, it is an example for null set. Next, y such that y is a point common to any two parallel lines. We know that two parallel lines, they will not intersect. Even though when you extend it, they will not intersect at any point. What is the condition is given here? We have to write how many points are intersecting between two parallel lines. So there are no points because parallel lines do not intersect each other. So this is an empty set, which is an example for null set. Next, we come across one more type of sets, that is finite and infinite set. As the name itself says, finite is nothing but countable. You can count a number of elements inside the set. Even empty set is also finite. Why? Because you can count that there is no elements inside the set. So therefore, empty set and a set consisting definite number of elements. So if you have 5, 6, 7, 10, 15 elements, you can count it. So any set which is countable is called finite set. And if it is not countable, then it is called as infinite set. For example, here I have taken, let W be the set of days of the week. How many days we have? We have 7 days in a week. So therefore, it is finite. That is, set W is finite. Second example, let G be the set of points on a line. So if you draw a line, we know that line can be drawn with continuous number of points. So if you draw a points, so if you have a line, you cannot count how many points are there because line is drawn by joining points. So therefore, it is an example for infinite set because you cannot count the number of points on a given straight line or any curved line. So therefore, G is infinite set. Next, let B be set of months in a year. Finite because we have 12 months in a year. Let P be set of all prime numbers. So we have infinite numbers of prime. So therefore, it is an infinite. When it comes to even prime number, it is finite because we have only one even prime, that is 2. But when it comes to odd prime numbers, it is infinite. In the same way, when it is come to prime number, it is infinite. State which of the following sets are finite or infinite. So the first question is given x such that x is natural number and given an equation x minus 1, x minus 2. We have to write the solutions of this set. What are the solution of this set? When you equate x minus 1 to 0, you will get x is equal to 1. And when you equate x minus 2 is equal to 0, you will get x is equal to 2. So therefore, this is the set for this one. So, and 1 and 2 are natural numbers. 1 and 2 are natural numbers. So we can count how many elements are there. How many elements we have? 2 elements. So this is an example for finite set. Next, x such that x belongs to n, x square is equal to 4. So what are the solutions for x square is equal to 4? If you have x square is equal to 4, then x is plus or minus 2. That is, what are the solution you have? Minus 2 and plus 2 are the solution. But what is the condition given here? X must be natural number. Minus 2 is an integer. Plus 2 is both integer and natural number. For this one, the only element you can have is plus 2. So therefore, this is an example for finite set because you can count. You have only one element. Next, x belongs to natural number. 2x minus 1 is equal to 0. If you have 2x minus 1 is equal to 0, then x is 1 by 2. But this is not a natural number. So what is the condition given here? X must be natural number, but 1 by 2 is not natural number. So therefore, you don't have any element here. So this is empty set. I said empty set is also finite because you can count. There is no element inside it. So empty set is also finite set. Next, x belongs to natural numbers and x is prime. I said set of prime numbers, set of even numbers, set of odd numbers are all infinite set. So therefore, this is an example for infinite set. Next, x belongs to n and x is odd. Odd numbers is also infinite. We'll take few more examples. Now, which of the following sets are finite or infinite? The set of prime numbers less than 99. So when it comes less than 99, so the condition is here less than 99. You can write all the prime numbers less than 99. So therefore, this is an example for finite set. and the set of positive integers greater than 100. So positive integers greater than 100 means after 100 you can write from 101, 102, 103 which are all positive integers, and it is not countable till infinite it goes. So therefore this is an example for infinite set. So the next question is the set of lines which are parallel to x-axis. So you are familiar with your coordinate axis, that is this is x-axis and y-axis. Perpendicular means exactly 90 degree to the x-axis. You can find number of lines which are parallel to x-axis, either a negative axis or positive axis. You can find number of lines which are parallel to x-axis. So therefore, this is infinite. Next, the set of numbers which are multiples of 5. Multiples of 5 starts from 5, 10, 15. So you can go on writing all the multiples of 5. Again, this is an example for infinite set. Next, the set of circles passing through the origin 0, 0. So if you have a coordinate axis, so this is your origin, that is 0, 0. So you can pass a number of circles. Okay, so passing through the origin, you can write many number of circles passing through the origin. So therefore, this is also an example for infinite set. So next we come across equal sets. What do you mean by equal sets? If you have two sets A and B, they must contain the same elements and same number of elements. So if two sets A and B are said to be equal, if they have exactly the same element, they should have the same elements inside it. So then we write it as A is equal to B, otherwise we write it as A not equal to B. So when two sets are said to be equal, that means they must contain same elements inside it. I have taken two examples here. So the first one, let A is equal to 1, 2, 3, 4 and B is equal to 3, 1, 4, 2. So you can observe here, in the set A contains the elements 1, 2, 3, 4. Also set B contains the element 1, 2, 3, 4. I said the order doesn't matter inside the set. The thing is the element should be in the set. So therefore, we can write A is equal to B because all the elements in A are in B and all the elements in B are in A. Next, C is equal to 1, 2, 3, 4. D is equal to 1, 2, 3, 5. So here 4 is not in D. So we can see here 4 does not belongs to D. Also here we have an element 5 which does not belongs to C. What is the condition? That all the elements of C should be in D and all the elements of D should be in C. But here it is not there. So therefore we write C is not equal to D. So from the given sets below, select equal set. So observe all the sets given here. You have A as 2, 4, 8, 12, B as 1, 2, 3, 4, C as 4, 8, 12, 14, D as 3, 1, 4, 2, E is minus 1, 1, F is 0, A, G is 1, minus 1 and H is 0, 1. So we are going to select equal set. So you can clearly see the set B and set D contain the same elements, that is 1, 2, 3, 4 and 3, 1, 4, 2. So leave the order, doesn't matter here. So therefore we can write B is equal to D. Next, one more set is E and G. E has minus 1, 1 and G as 1, minus 1. So I can write E is equal to G. So other than this, there is no other sets which are equal. Question 5. Find the pairs of equal sets, if any, give reason. So you can see here, set A contains an element 0. Don't confuse it as an empty set. It has an element 0. Next, set B. So I'm going to write set B here. So what is the condition of set B there? The element x, which should be greater than 15 and less than 5. So you cannot write any number which is greater than 15 and less than 5. So therefore this is empty set. That means it does not contain any element. And C. So if you put x minus 5 is equal to 0 as the equation, then the only element is 5 here. Next, D, x square is equal to 25. No condition of x is given, whether it should be a natural or integer. So only the solution we can write. So what are the solution of x square is equal to 25? One is minus 5, another one is plus 5. So plus 5 is nothing but 5. X is an integral positive root of the equation x square minus 2x minus 15 is equal to 0. So if you solve this equation, you will get two roots. So x square minus 2x minus 15 is equal to 0. That is x square minus 5x plus 3x minus 15 is equal to 0. When you solve it, you will get it as x minus 5 is equal to 0. So the roots are x minus 5 and x plus 3 is equal to 0. So that is x is equal to 5 and x is equal to minus 3. But what is the condition given here? It should contain a positive integral root. So the only possible element for this set is 5. Now we will compare all the sets and we will write it now. Now compare A and B. So we can clearly say A is not equal to B because it has one element and it is B. Compare A and C. So A is not equal to C and AD. So A is also not equal to D and A is not equal to E because no elements are same here. Next we will compare B with C. B is empty set. C contains the element 5. So therefore here B is not equal to C. Similarly B is not equal to D and B is not equal to E also. Next C and E. Yes, they are same. So therefore C is equal to E. But compare C and D? No, because minus 5 is not in C. So therefore C is not equal to D. And finally, we'll compare D and E. Yes, they are not equal because minus 5 is not in E. So that is when you are saying two sets are equal, all the elements in both the sets must be same. So here, in this case, we have written the pairs of equal set and also we have stated our reasons why they are not equal. Which of the following pairs of sets are equal? Justify your answer. X, the letters in the alloy, and B, the set of letters in the loyal. I'll take the first question. So if you write X as a set, I set alloy A, L, O, Y. Whenever the word is given in capital letters, you can write the elements in capital letters. And set B is loyal. So L, O, Y, A. Do not repeat any letter when you are writing inside the set. You can see X contain all the elements which are in B and B contains all the elements which are in X. So therefore X is equal to B. So this is the first question. And what is second question given here? A is integer such that its square must be less than or equal to 4. If I take a 0, 0 square is less than 4. If I take 1, 1 square is less than 4. If I take minus 1, minus 1 square is also less than 4. Similarly, minus 2 plus 2 gives 4. So 4 is equal to 4. And if you take minus 3, 9 less than 4 is not possible. Similarly, if you take plus 3, 3 square 9 less than 4 is not possible. So the only set you can write here is minus 2 to plus 2. Because these elements are satisfying the given condition n square less than or equal to 4. And about set B here, so I have to solve the equation x square minus 3x plus 2 is equal to 0. So when you solve this equation, so you will get two roots. That is, one root is x minus 2, another root is x minus 1. So if you equate them to 0, then the elements are 1 and 2. You can see here, A contains the elements of B, but B is not having all the elements in A. So you don't have minus 2, minus 1, 0 in B. So therefore, A is not equal to B. Next question. Are the following pairs of sets equal? Give reason. Let first one, A is 2, 3. B is the solution of x square plus 5x plus 6 is equal to 0. When you solve this equation, you will get two roots, that is x plus 2 and x plus 3 is equal to 0. So if you write this as a solution, so B is, when you equate this to 0, you will get the solution B as minus 2 and minus 3. Here you have plus 2 plus 3, but here you have minus 2 minus 3. So therefore, what I can conclude, A is not equal to B. Second question, X is a letter in the word follow. So if I write it, follow, F-O-L-W. And if I write B, which is the letter of wolf, so B, W, O, L, F. You can see W, O, L, F in A also, and A contains all the elements in B also. So what we can conclude, they are equal. So I'll write A is equal to B. So this is how we will recognize a null set, a finite, infinite or equal sets. So remember the definitions and the examples which we have taken it now, and learn the concepts in detail. So we'll meet you in the next session with the new concepts of sets. Until then, keep watching, keep learning and keep exploring. Thank you.